It's a pleasure talking to you today. Could you tell us more about your experience with EVs? You said you were one of the first employees in the 90s to be at this EV center.
Right, yeah, the EV Technical Center. So at the time, EVs were really much more of a R&D type of area, and there wasn't much out there. There were basically prototypes from manufacturers, and our job was to test them and basically prove that they could operate just as well as a conventional vehicle. And that was really the challenge there, is to prove that we could kind of do the same job. And the objective there, sort of a practical objective there, our CEO at the time wanted to bring in electric vehicles to the fleet, the SCE fleet, and so we really had a practical assignment there to find vehicles that could actually do the job. And we were concentrating on our meter reader fleet, and so what became sort of what started sort of as much more of a research type activity with the automakers and industry partners, became a practical effort, to find vehicles that could actually do the job in our fleet. And so we were pretty successful at that. But that was for the first 5 to 10 years of working here since 1996. That was the focus.
Right. How do you see electric vehicles fitting into the overall strategy for net zero at SoCal Edison?
We've done a lot of work here, actually, and we've published a few studies, and the most recent ones being our Pathway 2045 study and our Reimagining the Grid studies. And so those are really focused on what it takes to meet the state's greenhouse gas reduction goals, and so it's comprehensive. And so we've, on the technical side, we're working to integrate that work into practical matters like grid planning and the devices themselves that'll be needed. And so we spent a lot of work on DERs, distributed energy resources, and EVs basically being part of that set of devices. The idea is that those devices can be managed. And it's the grid of the future. I think it's much less of what traditionally has been sort of a central generation and then transmission, and more of an integrated system that includes resources, generation, and controllable loads, down at the individual customer level. And so we spent a lot of time on that, planning not only to make sure that the grid is going to be capable of supporting electric transportation, but all the electrification that we anticipate to meet the state's goals, but also working on the advanced technology and the controls and everything, which is a lot of what we do here, to make sure that we can serve that customer of the future. And so it's a lot of work, starting from those studies and then working through the traditional planning process, and bringing it all together and making sure that those plans are funded and executed, and we can continue to serve customers as the whole landscape evolves.
Right. It's almost like you read my mind. I was going to ask you about what you think the future of transportation looks like here.
Well, I think the electrification of transportation. Of course, I've been working on that for most of my 25 years here. But I think that it's electrification is going to have it's going to be a very large share, and I think eventually it's sort of a phasing time perspective on kind of how electrification builds out and how it plays out. But I've done a lot of work, not only in sort of the conventional transportation fields, sort of you think about passenger cars, that type of thing, but also in the commercial industrial fields, goods movement, so ships, trains, and I've worked on electrification in all those areas. And so there are practical,
Yeah.
solutions there, and they come down to funding and engineering, but they're all I think they're all available, and they're on the horizon, and we can expect them at some point. I think there'll be a blend going into the future, and they'll still be in certain applications. There'll be engines, air transport, things like that, and they're looking a lot at replacement fuels and that type of thing. But I think electrification is going to be something that's going to have a larger and larger share, and I think we'll be dominant in the future. We get out to that 2045 plus time frame.
Okay. What do you see V2G's role in electrification of transportation? Do you think that's possible, or the challenges with that?
Yeah, it's very interesting. I spent a lot of time in that area, and actually for a long time I've spent a lot of time in that area. It's not a new idea, but it's always been sort of chicken and egg type of thing. There are these use cases which are interesting, customer self-power or mobile power, backup power. These types of things have always been very interesting, but it's sort of been, okay, how much, to the automakers, it's always been how much really the customers have an interest in these types of things, and are they willing to pay extra for those features and that type of thing. But now, especially with products that's rolling out and the way that things have evolved, there appears to be a lot of interest, and the automakers are seeing that, and they're starting to build these types of features into the vehicles. So it's actually going to be available. And so I've talked a lot, sort of in industry technical circles, about V2G, and I've described sort of a spectrum of things, interests or use cases or applications, and going from kind of the simplest to the most complex. And so it looks like one that's easiest or easier to implement is the backup power use case. And we've seen this coming out from some of the auto manufacturers right now, and actually making products that can perform this function. So customers that might have a power outage, could they use their EV for backup power when the grid goes down? And so this seems to be, from a technical perspective, doable. The rules in place, interconnection rules, and their materials, switches, etc., that are available to do this, legally and effectively, according to codes that we have today.
Great.
And then there's sort of a lot of people think out to the hardest use cases, which are kind of the grid services use cases, where utilities would use EVs sort of for grid benefit. And so there's a lot of work we're doing there, and so maybe a little bit farther out on the timeline to get the controls in place that we need to kind of be able to see V2G assets and then manage them together with the grid. So it's very promising, and I think it gets more and more interesting when more and more vehicles get out there. So the numbers that we're looking at here in California, that are projected to be in place, really starts to pique the interest of the utility and the grid operators.
That's interesting. And one of the final questions we love to ask people is, what do you believe that other people may think is crazy?
There's probably a lot of those to choose from. But I talked before about sort of the old traditional way of the energy utility system, where you have the central generation and then the long transmission lines and the distribution lines and that type of thing. And so it's not particularly crazy to think about how much these DERs could sort of alter that model. But I think which could be considered pretty crazy. I think that that could even go a lot farther. Where you could have sort of larger generation resources that are out there distributed around. And I'm a tech guy, so I follow a lot of tech fields. Here for Edison, including storage systems, etc. But I also have some interest in the nuclear space, and so there's a lot of interesting things out there with small modular reactors and stuff like that. So that may get into areas that you might think were a little more crazy. That you might have some nuclear reactors out there kind of distributed around. But it's interesting to me.
Me too. Do you have any final words that you'd like to talk about or advice?
Well, I think I talk about this in industry circles and with the various organizations I work with, other utilities, and we've had a long history of working with the automakers together on electric vehicles, electric transportation. We try to do the same thing in the heavy-duty industry. And I just think that's been a very successful approach, and I think we should continue to do that, and make sure that we have a balance between the customers that are purchasing EVs, the automakers that are producing them, and the utility energy system to make sure that everybody's happy. And we want to avoid the potential of people being disappointed, and it could be a result of power outage or something like that, which we have really reliable power in the U.S. compared to some other places. But we always have strived to be the best we can be there, and we want to make sure that we don't run into situations where we're not prepared to serve all these customers that are purchasing electric vehicles. So we want to be ready for that.
Right.
And so we spent a lot of time on that. But I think the message is, we all need to work together and not have sort of a siloed approach where there's potential to kind of be out of step.
Lovely. Well, thank you for talking with us today. It's been a pleasure learning and adding to our EV adventure.
Thank you.